Sapelo Island is one of the many barrier islands located on Georgia's southeastern coast. Consisting of beach, dune, and marsh environments, the barrier islands formed as a result of changes in sea level rise during the Pleistocene and Holocene. Many of these islands, including Sapelo, are composite formations, consisting of the Pleistocene deposits landward, which originated when sea levels were higher than present, as well as Holocene deposits located seaward of the Pleistocene formations. In the case of Sapelo, the Pleistocene deposits are known as the Princess Anne and Silver Bluff Barrier Islands. While our class was at Sapelo, we experienced a storm event firsthand and ultimately came to understand how storms affect the environment of the island. In particular, these types of storms have the potential to affect both the beach and dune environments of barrier islands. Before discussing the details of the particular storm event, a quick discussion of the formation and processes associated with the beach and dune environments is necessary. The dune environment is characterized by the dominance of wind action and sediment movement and accumulation. As wind moves sediment up from the back beach, specially adapted vegetation helps to trap sediment in place. In fact, much of the plant life found on dunes is similar to that of other arid or desert-like environments. As the vegetation continues its growth upward, the sediment forms mounds that ultimately enlarge to form dunes. One of the most important organisms in the initial formation of dunes is Uniola paniculata, or sea oats. The fast vertical growth of this plant allows it to continually grow above the accumulating sediment, a feat that most of its competitors cannot accomplish. That is why the plant is commonly dominant on the crests of dunes. Because of their great importance to dune stabilization, they are protected by law in many states.
This diagram depicts the typical environments found on Georgia's barrier islands. Notice the separation of beach environments, starting at the seaward side of the dunes and continuing to the right. These environments are labeled on the diagram as the backshore, the foreshore, and the nearshore. Each of the beach environments are affected in their own unique way by the storms, prevailing winds, and longshore current direction. However, they all play a crucial role in the formation and transformation of the barrier island's characteristics. As shown in this picture taken on top of the primary dune at Nanny Goat Beach, there is a noticeable change in the beach environment at Sapelo. We have now exited the dunes and crossed over into the upper foreshore beach environment. One of the first things you may notice is the lack of plant life. The absence of plant life is due to the fact that we are now in a tidally affected area. At high tide, the beaches of Sapelo have an average of 8 meters of exposed sand during the summer months. But during storming events and increased tidal movements during the winter months, the seawater can cover this entire area, reaching all the way up to the primary dune. In this picture taken at Cabrera Beach, we are able to see a gently sloping nearshore environment. The outgoing tide begins to expose what was underwater only a few hours earlier. The nearshore environment is a thin zone directly seaward of the shoreline's high tide mark. Observing this outgoing tide, distinctions were made between the foreshore and the nearshore. The nearshore area extends from the shoreline across a zone of longshore sandbars and troughs. The nearshore environment includes the normal surf zone where breaking waves occur. The number of longshore bars present depends upon the gradient or slope of the nearshore environment. Generally speaking, the more gentle the gradient, the more bars will be present. Georgia's barrier islands are known for the gradually sloping beaches. We can now distinguish the separate features found within the larger category of the nearshore environment.
By their nature, barrier island environments are heavily influenced by storm events, ultimately serving to protect the mainland from the principal effects of such storms. However, the Georgia coast's position in the South Atlantic Bight, a large indentation in the southeastern coastline of the U.S., ensures that it is comparatively well protected from major actions of storms, currents, and waves. Additionally, the Georgia coast has a relatively high tidal range of 7 to 9 feet. As such, tides play the largest role in shaping Georgia's barrier islands. This is illustrated by the shape of the islands themselves. In contrast with North Carolina's long and narrow microtidal islands, Georgia's mesotidal islands have a characteristic drumstick shape caused by tide action, and are much wider than those in North Carolina. Wind direction is an important factor in characterizing interactions between storm events and barrier island systems. Georgia experiences prevailing winds moving from the north to southwest along its coast, and as such, most storms move in this direction. The worst storms that have the potential to affect Georgia's coast are known as nor'easters. These storms originate on the upper east coast of the United States and have been known to severely affect North Carolina and Georgia, although this is relatively rare. Effects include extreme coastal flooding and erosion. Due to its proximity to the ocean, the dune environment is one of constant flux. Indeed, storm events play a large role in dictating the destruction and relocation of primary dunes. Although dune formation via sediment accumulation is controlled by destabilizing wind forces and stabilizing vegetation, large singular storm events often heavily erode or destroy existing dunes, causing the formation process to begin anew. The extent of these effects depends on both the intensity of the storm surge and the elevation of the dunes. In this way, the back beach and dune environments are constantly being reshaped. In fact, the United States Geological Survey has created a 4-tier hazard scale for storm damage to barrier islands. The first level on the scale designates erosion that is confined to the beach area. The second level indicates semi-permanent to permanent dune erosion and retreat. The third level indicates destruction of the dune system and movement of the sediment landward. Finally, the fourth level indicates a storm surge that completely covers the barrier island.
The red marker shows the location of Sapelo Island. The majority of the sediment that is deposited on Sapelo Island is from erosion processes that occurred in southern Appalachia. Quartz and ilmenite grains travel down the Savannah River. During extended times of recurring precipitation or flooding, there is an increase in the amount of sediment that is carried by the Savannah. The yellow marker indicates the Savannah River Delta. As this sediment reaches the Atlantic Ocean, it then falls victim to the southern moving longshore currents depicted by the black arrow. Deposition along the shore, indicated by the yellow arrows, is the result of the angle and energy of the waves as well as the longshore drift. Before a wave breaks, it picks up sand and other sediment from the ocean floor. When the wave breaks on the shore, the underwater sediment is washed up onto the beach at a diagonal angle in which the wave is moving. As the wave washes back out to the ocean, gravity draws the sediment straight back out, perpendicular to the shoreline, and carries the sediment with it. Over and over, sediment and sand is picked up in one place and accumulates further down the beach. This causes a zigzag pattern of sediment movement down the beach. The red arrows indicate this perpendicular movement of sediment back out into the ocean. Here we can see that some ilmenite has been recently deposited. During large storming events, the beach can be covered by ilmenite, leaving a dark layer on the beach. If this layer is then buried, laminae such as this will be created. These laminae will typically dip seaward and are useful in providing insight into the history of the beach's deposits. Although it is rare, deposition of geologists may occur during storming events, much like the one we experienced while at Sapelo. Here we see one being brought in by the waves. However, he walked away. I think it is safe to say that he will not show up in the rock record.